Sonic, the heart of your system.
Hi and welcome to a new video. During Gamescom 2019 I was just meeting up with Gigabyte randomly to have dinner. We had a discussion about what's just going on in the hardware industry, talking obviously about Ryzen 3000, also about X570 and what makes the most sense when you're pairing memory sticks with Ryzen 3000. And I was under the impression that 3600 and 3800 MHz would be the most ideal or the highest memory speed you should run with Ryzen 3000, keeping in mind that the Infinity Fabric clock should run in synchronous mode with the memory speed. And then Gigabyte said, hey, we have something internally that we didn't release yet, but we can send it to you and you can test it, because we have something that has a much higher memory speed and typically can beat 3600 to 3800. And I was like, now that sounds interesting, and that's what we're going to test today. After Gamescom I received a package from Gigabyte including an X570 Aorus Elite motherboard and 4 memory DIMMs. 2 sticks were rated with 4933 MHz CL18 and the other 2 sticks were rated with 5000 MHz CL18, and that's extremely much. I've seen memory modules before with such speeds, but never in retail, only like special bins for overclockers, but nothing like this where you really have them like printed like that on a module and it seems to be rock stable. And when I saw those modules I was like, okay, maybe those modules support those speeds, but then what about the CPU and what about the mainboard? How much tweaking is necessary to get this to run? That's typically what we had with, let's say, C390 and 9900K. We saw a lot of like theoretical values and benchmarks at like 4600, 4800, benchmarks from vendors, but to reproduce it was really difficult. And my approach was to simply go into BIOS and load the XMP profile, and it worked. Those are the settings I'm currently using. So running 4G on the CPU just to have a stable CPU clock under all conditions. When you do benchmarks, it can be difficult if you have a boost or you don't know what kind of boost condition you're in. So it could have an impact on your benchmark values. That's why I fixed all the CPU cores to 4G for my testing. Loaded the XMP profile. You can see 5 GHz on the memory CL18, 27, 27, 38. It's showing 1.2 volt here, which is obviously not correct. If you just look at the modules themselves, the 4933 are rated with 1.5 volt and the 5 GHz modules are rated with 1.55 volt, which sounds much. I also applied this voltage. You can see I'm using 1.57 right now because I tried to push those modules even higher, but we can just lower that back to 1.55 for now. That was running rock stable. And talking about the voltage or just the general settings, I was wondering what kind of ICs are on those memory sticks, because if you take a look at the memory timings, we have CL18 and then it's TRCD 27, and that's, I would say, unusually high. If we're just working with Samsung BDI, for example, let's take a look at those G.Skill Trident Z Neo sticks, which are the new Trident Z sticks from G.Skill. They're rated at 3600 CL 16, 16, 16, 36, and that's what people are usually used to. So TRCD, the second value, is pretty much the same value as CL. That's very common if you use, for example, the Samsung BDI memories. And then we're seeing like 18, 27, 27. I decided to just take off the memory heat spreader of the 4933 modules and take a look what's underneath. Underneath, we can see a pretty simple memory module. There's no RGB on there because I heard in the past that sometimes RGB can have a negative impact or influence on the signal quality. Maybe that's one reason why there is no RGB on those modules. And if we take a closer look at the memory ICs themselves, we can see there is a small M on there, which is an indicator that those ICs are from Micron. Those are not Samsung ICs. And if we read the marking on the IC itself, it says D9WFL. Using Google, I just checked what those ICs are rated at. I did some more research and requested some data sheets from some friends, because those data sheets are not publicly available, at least from what I could see. And those memory ICs are rated at 3200 1.2 volt. So you can run a 3200 out of the box with those memory ICs, with all of them. Because typically, let's say even the Trident Z RGB memory modules, all of them are binned. So all of them are tested if they can pass those speeds. But if you take one of those D9WFL memory ICs, all of them are capable of 3200 at 1.2 volt, which means if you're overvolting them, let's say to 1.35, 1.4 volt, which is extremely common, you should be able to run 3600 or 4G across all of those memory sticks. I don't think that there is much binning required to hit like 3600 up to 4G. And those memory ICs are called Micron AIDA, and they're quite famous right now already, because Micron managed, or I think it was Ballistics, managed to set some world records with those ICs. I think they reached about 6G, so 6000 megahertz, and that's, I think, extremely impressive. And you can judge most likely by just looking at a TRCD value. When there's like 1827, that's a good indicator to have Micron, especially if you're aiming to get like ballistics modules. Most of them or all of them should be Micron. I'm not sure how you can be sure to get the D9WFL ICs that are on those extremely high binned sticks. Now, a lot of people might be wondering, is it a problem if you're running 1.5 to 1.55 VDIM on your memory modules? Is that a problem for the memory controller? From what I've heard, it's not. I personally ran some tests above 2 volt for multiple times, and it was never an issue. I talked to most of the mainboard vendors, and they also confirmed to me that they're not aware of any problems with high VDIM, and the CPU IMC seems to be no problem whatsoever. And those Micron ICs are rated at maximum operating voltage of 1.5 volts. So IC-wise, that should be no problem at all. I mean, if they're rated at 1.5 volt and you're pushing them to 1.55, that's just small over voltage, and I think that should be safe. It's the same what we're doing every single day when we're overclocking CPUs. We're always running them outside spec, and you know how rare it is to really encounter problems if you're increasing it only by such a very small margin. Most of you are already aware about this, but I will just repeat it once again. So for example, on the 3900X Ryzen 3000 CPUs, we have 3 chips in total. We have one bigger chip in the middle that contains, for example, the memory controller, and we have 2 smaller chips on the bottom. Those are containing the CPU cores. And the memory controller and the CPU cores, those are connected with the fabric clock. And in the ideal condition, the fabric clock is half of the memory clock. So for example, we're running those Trident Z Neo memory modules with 3600 CL16, and in this condition your fabric clock ideally should be 1800 megahertz, and then your fabric and memory clock are running in synchronous mode, which leads to the best latency and typically to the best performance. But we can also run, for example, the 5G that we're just doing right now. You can see in CPU Z I'm running 2500 megahertz on the memory, which is then with double data rate 5 gigahertz. And if we switch over to the Ryzen Master, you can see fabric clock, it's German, but this is the fabric clock with 1800 megahertz. Don't be confused with what shows the Northbridge frequency in CPU Z. Some people are confused, or I was also confused, because I thought for this board it would read the fabric clock, but it's not. It's reading a different one. So just to be sure, if you're checking your fabric clock, maybe double check with Ryzen Master and check for fabric clock right here. In this condition, we are not running the synchronous mode, we are running the asynchronous mode. And the asynchronous mode, it's nothing bad, but it's adding a latency penalty because the data has to be synchronized again once in the memory controller. And that is typically adding a penalty of 8 to 12 nanoseconds from my experience. And yeah, that leads to a performance penalty as well, depending on what kind of benchmark, what kind of condition you're running. You're encountering a penalty in performance, but we can just simply run AIDA 64 cache and memory benchmark just to show you that this system is really running. I performed a ton of tests over the last 3 days. All the configurations I tested, even this is memtest stable, is Prime 95 stable, tested multiple applications like 7-Zip or Adobe Premiere. So this is rock stable. You can see the read performance is 5600, while the write performance is almost also 5600, it's 55900 right now. Copy is even higher. That is extremely impressive on this configuration. We're above 60-100 megabyte per second in copy. Yeah, you can see 466. Obviously, currently I'm also running CPU-Z and Ryzen Master in the background. Typically, if I'm performing benchmarks, I'm closing all applications in the background, which I didn't do right now. So this is a little bit different from my benchmark values, which I took over the last 3 days. But you can see 75.7 nanoseconds right here on latency, which is a little bit higher than what you would see if you're running, let's say, 3600 in synchronous mode with 1800 Infinity Fabric. So that's obviously the negative aspect, but this is running rock stable. But let's just take a look at some benchmarks so we can really see if there's a benefit running this configuration or not. Before we start off with the benchmarks, a quick comparison with CPU speed, because I was running all benchmarks at 4 GHz and I was not sure if this is enough or if there is a limitation to the CPU, and that's why I did a second quick test with 4.3 GHz on the CPU. You can see the top line is 5 GHz on the memory CL18 with 4 GHz on the CPU. Bottom row is 5 GHz again on memory CL18 but 4.3 GHz on the CPU. Read, write, copy values are basically the same. Those are the average out of 3 runs, but I would say that's kind of measurement tolerance, what we see, the fluctuation between those runs. So I would say there is no limitation by running the CPU just at 4 GHz. Starting off with AIDA 64 read test, and just a quick explanation. You can see the green lines are the 5 GHz modules from Gigabyte. Everything that is marked blue is running in synchronous mode, and everything that is marked yellow is running in asynchronous mode. The line in between with this blue pattern, the 3800 C16 and 1900 on the Fabric clock, is not stable. This one did not pass memtest or Prime 95. I still kept it in there because it was stable enough to pass the AIDA 64 test, just for you as comparison values, but this is not 24/7 stable. That's why I gave it a special marking. Going back to the chart itself, you can see that the chart is led by the 5 GB C18 with 1867. Obviously not every CPU can run 1867, so you should be kind of careful with those values. Same goes with the one that's underneath with 3733 MHz C16 running in synchronous mode. Those are the G-Skill sticks with 1867 on the Fabric with 57 GB per second, but the values underneath are more values that you would be able with most of the CPUs. So 5 GHz on the memory modules CL18 with 1800, resulting in 56 400 megabyte per second, followed by the 3600 1800, which is the most common, I would say, high-end configuration on Ryzen 3000. So 3600 CL16 running in synchronous mode, resulting in 55 megabyte per second, and everything underneath, or you can straight see the penalty. If you compare the 3600 1800 to 3600 1867, you can see even though the Fabric clock is higher with 1867, the resulting speed is lower, and that's due to the latency penalty right here. And that shows why you should stay typically with the synchronous mode. And everything underneath, like 2666 or 2133, those are really memory speeds I would personally try to avoid, because you lose so much performance using those kind of memory modules. AIDA 64 write test is led by the 5 GHz modules from Gigabyte, followed by the 3733 MHz C16 with 1867 MHz on the Fabric, followed by the 3800 C16 1900, and you can see probably because it's not entirely stable, that's why we lost a little bit of performance here, not sure, but it was reproducible. That's why I also marked this as, yeah, kind of take it with a little bit of salt. With the AIDA 64 copy test, it's even more obvious that those modules perform just when you're looking at plain read-write copy test. The 5 GHz modules from Gigabyte are performing extremely well, so they're leading the chart with a good margin, followed by the 3733 with high fabric clock and the 3600 typical configuration. C16 1800 fabric is with 54644 megabyte per second, and that's about 10,000 megabyte per second less than the Gigabyte 5 GHz modules. The AIDA 64 latency test is really showing the penalty of not running the synchronous mode. You can see this is clearly led by the synchronous mode, 3733 with 1867 with 68.3 nanoseconds, followed by 3600 C16 1800 fabric clock, and this is about 5 to 6 nanoseconds faster than the 5 GHz modules from Gigabyte. And probably even if you're running 6 GHz on those modules, you would not be able to catch up with the low latency due to the fact that the data has to be synchronized once again in the memory controller. But yeah, you can see we have a penalty in the latency, but the read-write copy values were still better than in the synchronous mode. In Cinebench R15 Multi, I think most of those runs are within measurement tolerance, at least starting from the 3733 on top down to the 5 GHz C18 with 1867 fabric. All those with like 13 points up to 20 points. Those are the average across multiple runs, but even then there is a decent variety during the runs, so I think all of those are pretty much equal and should be treated as measurement tolerance. Just with 3200 and below, you can see we're losing performance. Pretty much the same in the single threaded test. Most of the high-end configurations have 189 points, so 5G down to the 3600 with 1800 synchronized fabric clock. They all perform pretty much the same. 1 point less for the asynchronous mode with 3600 with 1867, and everything below we lose a little bit performance with like 3200 or 2133. AIDA 64 values are certainly nice to look at, but the question is, how much does this really help us if we're doing real-world performance? That's why I performed some rendering benchmarks with Adobe Premiere, simply rendering one of my 4K YouTube videos. You can see the chart again on top, 3733 MHz synchronous mode, the Trident C Neo sticks with 1867 MHz. The Gigabyte modules with 5 GHz are a little bit slower with about 8 seconds penalty. And if we go lower in the chart, for example 3200 MHz, we're losing already 1 minute, and 2666 we're already losing 3 minutes, and 2133 we're losing 6 minutes of rendering time, and this just shows how important memory speed, at least 3200 MHz, is for Ryzen 3000. Last test is 7-zip compressing time. Took one of my 4K YouTube videos with all the files that are included, like screenshots and music files and everything. So in total 170 files with 41 GB total. And surprisingly, the 5 GHz modules from Gigabyte are the fastest option in this case, with about 10 seconds faster compared to the G.Skill modules running in synchronous mode. Also here, if you take a look at the bottom of the chart, like 2666 or even 2133, 2133 is almost double the time for compressing, and that's ridiculous. I didn't think that this has such a massive impact. Before we get to the conclusion, one more thing I would like to highlight or point out is that you really have to be careful with the temperature of those modules. Obviously 1.5, 1.55 volt are resulting in a high power consumption, or fairly high power consumption for memory modules. That's why you should always have a good airflow across your memory modules. When I was testing with zero airflow, Prime 95 or MemTest, those sticks were getting unstable at like 65 or 70 degrees Celsius, and if you just have a fan on them, it's totally fine, you're not encountering problems. But if you're using them in a closed case, make sure that you have some good airflow across your modules. Okay, so what's the conclusion of everything that we just talked about? Is it really worth getting 5 GHz memory modules, and to answer this question I would need to know the availability of those sticks, and I don't even know if they will ever be available in retail. And I don't even know if they are, or if they're going to be available, what the price will be. In general, I can say in most cases they are beating the Samsung B-Die or are at least on par. For example, 7-Zip they're beating, AIDA 64 they're beating everything, and in Adobe Premiere they're basically the same performance as running a high synchronous B-Die kit. And for example, if you're one of the HWBot guys and aiming for the highest possible memory clocks that you want to put into the database, then you should probably get some Micron based sticks like those Aorus based kits, because they will be very easy for you to achieve extremely high memory speeds you would not be able to get with Samsung B-Die. Otherwise, if you're asking what kind of memory configuration you should get for a normal gaming PC, I think still 3600 with synchronous mode is a very good choice and a very good kit to get. Otherwise, I'm extremely impressed that 5 GHz out of the box are just working. You just plug it, load the XMP profile, and it works. I never expected that. So if you have no budget, if you want to have the highest memory speeds ever, you should probably get one of those kits if they will ever be available. Thanks for joining in. See you next time. Bye.